Welcome again to the Rome Transformed 10 Minutes Talk series. My name is Thea Ravasi. I'm the Archaeology Research Associate, co-drafter of the project and coordinator of the Structural Analysis Data Capture exercise. My research focuses on Roman residential and thermal architecture. If you wish to know more about what I do, please check out my profile on our Rome Transformed website. In this video, I'm going to present you a short introduction to the architectural and structural analysis methodology for the project. If you haven't done so, and before watching this video, please check out my video on the archaeology of Rome Transformed. Rome Transformed methodology encompasses four main steps: data collection and interpretation, including archival research, structural analysis, 3D recording of buildings, geophysical survey, and environmental analysis. Data integration in a 3D GIS, the development of 3D models of the urban fabric of the Eastern Caelian in key time slots, and data and model sharing via dedicated online platforms to guarantee maximum transparency in developing 3D visualizations. To know more about our methodology, please check out the Rome Transformed About and Methodology tabs in the project website, https://research.ncl.ac.uk/Rome and subscribe to our YouTube channel, where we will upload further videos on our research methodology. The structural analysis of existing buildings focuses on the multiple multi-layer archaeological areas, including areas with exposed structures underground and areas above ground, 4 tracts of the Neronian aqueduct and 1.5 kilometers long tract of the Aurelian walls. Some of these areas, such as the scavi underneath the Lateran Basilica and in the Ospedale of San Giovanni, have been already analyzed as part of the Lateran project and of the San Giovanni Laterano II project. In order to optimize our data collection and management strategy, Rome Transformed Research Area has been divided in 7 districts, areas 1 to 7, and 2 monumental structures that bind the research together: the Neronian Aqueduct, area 8, and the Aurelian Walls, area 9. To avoid pre-interpretation, structural analysis areas are coded via a unique ID number that corresponds to one structural complex, being it a building in a single phase or a series of buildings overlapping one onto another and representing distinct structural and functional phases in the area. So, for example, SA 4.1 corresponds to a columbarium in its main structural phases, while SA 1.1 corresponds to 3 separate phases: from bottom to top, a 2nd century elite residence, the Severan Castra Nova, and the Constantinian Basilica. You can discover more about each structural analysis area by checking the Archaeology tab of our Rome Transformed project and explore our online interactive maps, area by area. This video is aimed at both specialists and a general audience, so before explaining our structural analysis data collection strategy, I will introduce some of the very basic concepts that underpin our archaeological analysis. Stratigraphy is the study of layered materials that were deposited over time. By assessing the stratigraphy of a site, archaeologists generally determine the sequence of human actions and of natural activities occurring on a site, and establish the chronological order in which they took place. Contexts are single events or actions that leave discrete, detectable traces in the archaeological sequence or stratigraphy. So, for example, the construction of a wall is made of a series of building sequences that can be summarized in the following actions, named contexts. So the first one here you see is the natural soil that has been numbered as number 1. The cutting of the foundation trench is recognized and identified as an action and therefore numbered as context number 2. The construction of the foundation is context number 3. Then the filling of the foundation trench, which is numbered 4. And the construction of the wall on top, which is recognized as a distinct action and therefore numbered as context number 5. Our data capture exercise aims at understanding and recording the sequence of building activities that are detectable on site. However, unlike what normally happens in an excavation, subgroup rather than context is the first step in our data collection process. Our subgroup data recording means that during our structural analysis exercise, we aggregate individual context into larger groupings, subgroups, based on their stratigraphic position and interpretation. Each subgroup consists of a context or a small number of contexts which are immediately related to each other and of the same date. In the following slides, I'm going to guide you through the subgrouping process by looking at the evidence provided by the house discovered in the Ospedale di San Giovanni, our SA 2.1 area. Here, for example, you see two walls that may or may have not been contemporary in their construction, and that are the earliest building evidence detectable on site. They are therefore being given a subgroup number each that may or may not eventually be paired after the analysis of their chronology. The opening between the two walls is walled up at some point. This means that the third subgroup can be detected that corresponds to a unique building action on the site, number 3. A fourth action takes place, the plastering of the wall that could not also be contemporary to the walling up detected before. In this case, we keep the two subgroups distinct and add a further fourth number that will or will not be grouped to 3 after an overall examination of the overall phasing of the room. Same happens for the laying of the marble floor. Again, this could be, but also could be not, part of the same construction process of wall 3 and wall decoration 4. As we are not sure, we will give it a new number, number 5. Finally, the ground floor of the entire portico is raised and a new floor of tile is placed on top. This can be considered, by careful examination, the result of two distinct actions, the raising of the floor by adding soil and the laying of the tiles on top of it. The two contexts are grouped together in one subgroup, number 6. The destruction or backfill of the floor could not be, however, in the same subgroup as the floor, as they are not contemporary. Subgroup numbers are coded in relation to the structural analysis area where they are taken in order to avoid number repetitions across the whole research area. Our structural analysis subgroup coding system is detailed in the Rome Transform project manual. All our subgroups are recorded on site by looking directly at the structures. Data are then filled in our structural analysis database designed by my colleagues David Heslop and Alex Turner. To know more about archaeological analysis and interpretation of architectural structures, please check out chapters 2, 3 and 4 of the Historic England Excavation Recording Manual published in 2018, available for download online from the link below. Dealing with historical excavations poses in itself a number of challenges. Accessibility. Not all the structures are easily accessible as they lay underground in narrow and difficult to reach spaces. This means that our field recording alongside 3D data capture may be sometimes the only opportunity to effectively gather meaningful data. Visibility may also be an issue when dealing with historical excavations, when, for example, saline infiltrations make the surface of the walls almost illegible. And here you can see the difference between brickwork visibility before cleaning done by restorers in the area of underneath the Lateran Cathedral in 2019 and after cleaning to the left. Structures also can be truncated by later elements that make assessing structures in their entirety a challenging work, especially in underground spaces. And you see here the help that scanning can give us when dealing with similar situations. Here you can clearly see the overlapping and intersection between the walls of an elite residence underneath the Lateran Cathedral, that is highlighted by the frescoes that are visible in front of you, that was later destroyed by the construction of the Castra Nova, with this large grid of transects that make it impossible really when we are on site to look at the walls of the domus of the lighthouse in their entirety, in their complexity. Finally, some sites were discovered decades, if not centuries ago. This means that we are often left with the wall structural stratigraphy, but that we have lost any information about soil stratigraphy. This makes it more difficult and sometimes impossible to date precisely the structures themselves and to understand the original function of a space in its transformations over time. Moreover, dealing with historical excavations may also mean that we have to distinguish original fabric from historical restoration. This can be also very challenging when the latter is itself aged, old, or weathered. So how are we going to respond to these challenges? The first response to the structural analysis challenges is provided by the unique composition of our team that brings together people with a long-standing experience in structural and architectural analysis and an expertise on the analysis and assessment of the building that are part of the Rome Transformed research area. I have widely researched on Roman brickwork architecture in Rome and Latium, and have worked on the archaeology of the Lateran and of the Ospedale di San Giovanni Laterano districts, often dealing with historical restorations and reassessment of old excavations, such as the Hadrian's Villa at Tivoli, discovered under the Lateran baptistry and under the Ospedale di San Giovanni. For many years, I have also worked alongside and benefit from the experience and insight of my colleague David Haslop. David is an archaeological consultant with a long-standing expertise in field archaeology and building recording. Together with Alex Turner, David has designed the project's structural analysis recording database that will feed into our Rome Transformed GIS. Our team also benefits from the experience and insight of my colleague Dr. Francesca Carboni. Francesca has joined our team in Newcastle in 2019, and she brings with her an expertise and fieldwork experience on the archaeology of late imperial and early medieval Rome, further expanding our ability to tackle complex and multi-phase structures. In 2021, we will also be joined by a group of scholars and researchers that over the years have been involved in the study, excavation and recording of many of the structures discovered in the archaeological complex of Santa Croce: Marco Solvi, Tiziana Darmini, Sergio Palladino, Donato Colli and Laura Bottiglieri. Their knowledge and expertise will be indispensable for the analysis and assessment of this fascinating area of our project. As often we lack vital soil stratigraphy, we are left with walls and structures that, despite being still capable of giving us meaningful architectural and archaeological information, have often been stripped of all the available information that would have otherwise helped us to establish their precise chronology, construction, use and destruction dates. It is therefore paramount that we adopt every possible means to assess our structures. These include, for example, the possibility to establish comparisons between the brickwork and the building techniques of well-dated complexes with nearby structures that may be coeval and part of the same building process. Our general assessment of the brickwork and building technique has so far focused on the nature and use of relieving arches and on the quality of brickwork and mortar of some of the structures underneath the Lateran Cathedral and the Lateran Baptistry that can be fairly accurately dated, with the aim of comparing them to structures exposed in areas SA 2.1 and 2.2 of the Ospedale di San Giovanni that are similar in their layout and structural function. The observation was carried out using a Dynolight digital microscope that allows for 200 times magnification and portability, a particularly useful feature in underground environments. The visual assessment focused on type, quality and size of tiles and bricks, the quality and thickness of mortar, especially in relationship with the structural function of the wall, the presence of reused bricks and tiles, traces of finishing touches such as vertical hammering and horizontal polishing on brick surfaces, and finally the quality of grouting. The analysis is ongoing and will be completed by evidence provided by the analysis of 1 square meters portions of the walls from the laser scan recording of the structures, following the model suggested for the analysis of the Aurelian walls developed by Maura Medri and her colleagues. But preliminary observations permit us to suggest significant analogies between some of the structures in areas 1 and 2 and the brickwork of some of the structures in the Lateran area, such as the western external wall of the baths underneath the Lateran baptistry, dating to the Severan period and likely completed under Caracalla, the southern wall of the Principia of the Castra of the Equitas Singularis, and the apse of the Constantinia Basilica. The second way to respond to our current challenges will be to assess information derived from the archaeology against information on historical excavations that can be retrieved from Rome's archives. The archival research team is coordinated by my colleague Dr. Francesca Carboni. So far, we have already looked, for example, at the documents from the archive of Valnea Santa Maria Scrinari, who excavated the grounds of the Ospedale di San Giovanni, our Area 2. We are using the information from the archive to assess the nature of Scrinari's excavations, including the restorations, and to gain further evidence now not available anymore on site. Dr. Duncan Keenan-Jones from the University of Queensland, Dr. Davide Motta from Northumbria University, and Elettra Santucci, who is joining us for a PhD on hydraulics, will bring in their invaluable research experience on Roman hydraulics and water systems in Rome, Ostia, and Pompeii. Over the years, we also have developed, and we hope we will be able to develop further collaborations with specialists of single aspects of our research, such as Dr. Nicolò Mognai, who has provided invaluable help in documenting and preliminary assessing the architectural decoration of the scavi in the Ospedale di San Giovanni. If you want to discover more on our data capture methodology, please check the methodology tab on our Rome Transform website. This is all from me now. Thank you for listening to my presentation and see you the next time.